Good morning, this is Mr. Morales. I'm going to explain to you today how to use and apply the quadratic formula. Now first in our notes we're going to have a bit of reviewing. We're asked to solve by factoring the equation x squared plus 2x equals 15. According to what we've been doing, the best way we know how to factor is to get everything on one side of the equal sign so that our equation equals 0. So in this case I subtracted this 15 from the right side from both sides of the equation and I end up with the equation x squared plus 2x minus 15 equals 0. And this one's a nice quadratic equation because we can easily get the two terms that the two numbers that multiply to give me negative 15 and add to a positive 2, which would be positive 5 and negative 3. And that's kind of been where we've been at so far. But now we're going to learn how to factor equations that maybe aren't so easy to manipulate. So we're going to use the same equation and we're going to practice what's called the quadratic formula. Now a quadratic is any equation that has where the highest exponent is a 2. And that's what we've been dealing with for the last week, whether you've realized it or not. Now, when the equations are written in order from the highest exponent down to the lowest, or to the last number with no exponent, then we call that the standard form for a quadratic. And then a lot of times many of these variables, the x squares and x's, will have coefficients. So we're going to call whatever number is paired with x squared, we'll call that a. We're going to call whatever number is paired with the single x, or x to the first power, we're going to call that a b. And then any other number that's attached that doesn't have a variable, we'll call that c. Now here is the equation. And yes, at first it looks very complicated, but at some point you will end up memorizing it and knowing this by heart. The way you read it is x equals negative b plus or minus, that's right, plus and minus, the square root of b squared minus 4ac over 2a. What's brand new and about this, especially other than it's being so long, is the plus or minus symbol. Basically what that means is at some point you're going to end up doing some addition, and then at some point you're going to redo the equation and do some subtraction. And you'll see that as we go through our first example. So our instructions are solve each equation using the quadratic formula. Round answers to the nearest tenth. So what I did here in our notes is I went ahead and I'm going to go ahead and show you how to use this formula. So first of all, what we have is our x squared. And if you don't remember, we basically have an imaginary 1. And then we have 2x minus 15 equals 0. So with the fact that it equals 0 already tells me that it's in standard form, and I can go ahead and use this formula. So whatever's with x squared, that number, that coefficient, is my a. So this 1 and a are assigned to each other. Whatever number is with my x, that's my b. In this case, that's a positive 2. So in the category for b, I have a positive 2 there. And finally, whatever number is attached at the very end is my c value. In this case, that's a negative 15. Remember, subtraction in algebra can be both a negative or mean subtraction. And in this case, we're going to carry it over as a negative 15. Now, first step is to always write your equation. X equals negative b plus or minus b squared minus 4ac over 2a. And yes, you do have to write it every time because it's very good to practice it, and it's almost impossible to try to do this all and keep it organized in your head. So your best bet is just to write the formula down every single time. After I write the formula down, my next step is to substitute in my values. So I remember that b was a 2, but my formula says make whatever b is, that negative sign means to change its sign. So if it was a positive 2, then it becomes a negative 2. Plus or minus the square root symbol, or the radical symbol, and then I have b squared, which is 2 squared. It is important that no matter what b is, and if you're going to be using your calculator, which you will on this assignment, to always put the b value in parentheses, not only on your paper, but also in your calculator, especially when you have negative numbers. So I have in parentheses 2 squared minus 4 times my value for a, which is 1, times my value for c, which is negative 15. That's all on the numerator part of this fraction. Underneath, it's 2 times whatever a is. 2 times this positive 1 right here. So all I did was just substitute in all the values. I haven't even done any calculations yet. Now, what you need to do now in order to start working this equation out is to do what is underneath the radical symbol here only first. There's no way you can add and subtract at the same time on any calculator that we have. So just do what's under the radical symbol. If you do this correctly with the parentheses, the equation then will boil down to x equals the negative 2 plus or minus the square root of 64. All this information underneath the radical symbol should give you a positive 64 over 2 times 1, which is 2. Now we go back and we know that 64 is a perfect square, so we know the square root of 64 is 8. And that brings us to our last step now. X equals, we still have that negative 2 in the front, and now we're going to address that addition and then that subtraction in two different steps with 8 divided by 2. So first I'm going to work this piece out with just the addition symbol. So x will equal negative 2 plus 8 divided by 2. Negative 2 plus 8 is a 6, divided by 2 is a 3. So what we're going to end up having is two separate answers. So my first answer is going to be a 3. Now if I do subtraction, I'm going to do 2 minus 8, negative 2 minus 8, excuse me, which is a negative 10, divided by 2, which gives me a negative 5. So one of the big ideas is that when you're solving quadratics, you're going to end up with two answers. X is equal to negative 5 and 3. At two different points, if we were to graph this equation, which we will at some point, you would see that it has x-intercepts at negative 5 and positive 3 on the x-axis. And that's basically what this is all about, finding those x-intercepts without making a graph. So let's go ahead and practice and turn your page over and let's start the next example. Example number 2 on the back is really broken down to us in standard form. So I go ahead and assign my values for A, B, and C. A is negative 2, B remains negative 4, C is a 3. I write my equation for the quadratic formula. Then I'll go ahead and step 2 and I'll substitute all my values. Don't forget that the first step in the quadratic formula is to take B and change its sign. So since B is a negative 4, when I plug it into my equation, just in this first part only, it becomes a positive 4. Wherever I see it in the rest of the equation, like I do over here, it reverts back to a negative 4. And for this example, especially when you use your calculator, it is very important that you keep this negative 4 in parentheses with the exponent on the outside. Otherwise, you will get an erroneous answer. So I've substituted everything in. I didn't mean to smear my notes there. And when I do all this, I get something that's very interesting. I get not a perfect square, but the square root of 40. And this takes us back to one of our previous lessons. 40 is not a perfect square, which means I have to break it down and I have to write the simplified version of 40, the square root of 40. So as a quick refresher, I took the square root of 40 and I said 40 is also equal to 2 times 20, which is also equal to 2 times 10, which is also equal to 2 times 5. So I got all the prime numbers that make up the 40. I know I have at least one pair of 2's, so that becomes the number in front of my radical symbol, and then what remains is this 2 times 5, which is a 10, and that goes underneath the radical symbol. So the square root of 40 basically turns into this whole piece, which is why we studied this process. So I will now write it as x equals, I get this equation, x equals 4 plus or minus 2 square roots of 10, because that's what the square root of 40 is simplified to, divided by negative 4. So there's two ways to write your answer now. You could just write with the algebra and say, okay, well, 4 plus this thing right here divided by negative 4 is one answer, or 4 minus 2 square roots of 10 divided by negative 4 is my second answer. This would be the algebraic form. Or we could round it and get an actual decimal answer.